Okay, question 22 is a probability question. And given how far on it is in the paper, it's probably a tree diagrams question. And they gave you quite a lot of space in your answer sheet to work this out. So it says a bag contains 10 counters, red or blue. So 10 counters, red and blue. So the counter is taken out of the bag, not replaced, and a second counter is taken out of the bag. So even though we don't know how many counters there are, on this first part of the tree diagram, we know that it's going to be out of 10. And because the counter's not put back in, when I do red and blue over here, I know these are going to be out of 9. It said the probability of at least one counter being blue is 48 out of 90. Now, if you've been practicing your probability questions, you should know that if you ever see at least questions, so at least one blue, that would, if we were working out that probability would be the same as doing 1 minus the probability of getting no blues, because it's the only thing that can't happen. If we get at least one blue, we get either a blue and a blue and a red, or a red and a blue. So the only thing that we're missing is no blues. And because all the probabilities add up to 1, if we do 1 minus the probability of no blues, we'll get the same as doing the probability of at least one blue. So we're told that that is equal to 48 over 90. That means the probability of having no blues because 1 minus the probability of no blues is 48 over 90. If I do 90 minus 48, that will tell me the probability of having no blues. So that's 42 out of 90. Now, I've been saying no blues a lot, but that's also 2 reds. Red and red. So we've got this fraction here times this fraction here must equal 42 over 90. Right, well, what can the top numbers be? Well, we also know that if I take out one counter, if I originally say I've got X red counters, if I take one red counter out, I will have X minus 1 counters left. Like if I took out 5 counters, if I had 5 counters here, if I took a red one out, I'd have 4 left. I'd have 1 less than I had before, so X and X minus 1, which tells me my two numbers need to differ by 1. So I'm looking for two numbers that differ by 1, in other words, two consecutive numbers that times to make 42. So, for example, 1 and 2, they don't work. 2 and 3, that's only 6. 3 and 4 is 12. 4 and 5 is 20. 5 and 6, we're getting closer, it's 30. 6 and 7 make 42. So this is what we're looking for. This number must have been 7, and the smaller one must have been 6. 7 times 6 is 42. The question says how many counters were red. 7 counters were red. This number here, 7 counters. So that's what we were looking for.